So in this video, we're just going to work through examples 4 through 6. We're going to find it's a variation on the binomial expansion, and specifically, we're only going to be asked to provide a certain number of terms. Example 4 is asking us to give the first three terms of 2x plus y squared, that expansion to the 10th power. Well, a equals 2x, b equals y squared. How do we get started? Write our first coefficient, 10, 0. That's a 10c0. What do we have? Well, the b must be to the 0 power, so that'd be y squared to the 0. I won't write it this time just to save ourselves a little bit of space. What are we going to have with 2x? That's going to be 2x to the 10th power. Next term, 10, 1 becomes our coefficient. 2x to the 9th power, powers descend, remember, b must be to the first power, so that's y squared to the first. Next, plus 10, 2. Well, what are we going to have? We're going to have 2x to the 1 power less than we just had, to the 8th power. Y squared, which we'll find out becomes y to the 4th. Let's do a little work below. Well, it turns out that, I'm just going to point through these numbers, then I'll write my final answer off to the side. 10c0 is a 1, so the first term becomes 2x to the 10th, which is 1024x to the 10th. 2 to the 10th is 1024. A 10c1, 10ncr1 becomes 10. 2x to the 9th power, 2 to the 9th is 512. So I have 512x to the 9th. Just put parentheses around because we're going to multiply those two numbers in a bit. And it becomes y squared, just y squared. My last piece, if I do a C10, 2, that's what that is, that becomes 45. 2x to the 8th becomes, 2 to the 8th is 256, 256x to the 8th. And y squared squared, that becomes y to the 4th. So if you just do a little simplification, what am I going to need to do? Well, I'm going to need to multiply my 10 and 512 in that term, my 45 and 256 in that. A final answer that I'll come out with is 1024x to the 10th plus 10 times 512 is 5120, x to the 9th, y to the 2nd. 45 times 256 becomes 11,520 plus 11,520 x to the 8th, y to the 4th. And there's our solution for the first three terms. Okay, let's go to our next problem. I'm going to just change pieces of paper just because it's visual, be a little bit easier to see. Example 5 says give us the fourth term in the expansion, x plus y to the 15th. A equals x, y equals b, fine, no problem here. Now, in the book and here in the notes, we give you the formula for term k in the binomial expansion. It's a little bit maybe messier than we need. It works. It's fine. N to the r, there's a coefficient where r is k minus 1 times a to the n minus r, b to the r. Great. It's a wonderful formula. It'll work, but I'm going to show you a different way to build this. I think you'll become more comfortable with it. And you see it right here in our notes. And the reason is, we talked about before, if I know what my coefficient looks like, my combination number that I use as the coefficient as part of the expansion for each individual term, if I know a particular coefficient, I can write the a and b parts very, very simply. So let's look at that very quickly. This is term 4. Well, I know, and it's also an expansion to the 15th power, so I know that my coefficients are going to look something like that. I'm going to have a 15 in all of them. Well, term number 1 has 15, 0. Term 2 has 15, 1, right? We keep building going across. The next term is 15, 2. The next one is 15, 3. Now, I just, for tidiness sake, I'll go ahead and mark it up. Well, what do we notice? The fourth term has a bottom component in the binomial coefficient, this little combination that we do, that's 1 less than 4. The fourth term, remember, just count 0, 1, 2, 3. I know that my coefficient for term number 4 has to look like 15, 3, 15C3, C, 15, 3, whatever language we want to use. Well, I now know that's the term that I want. The fourth term is going to have this structure. And what else do I know? We said I can look at this coefficient and figure out what I need to do with A and B. In this case, namely, A is X, B is Y. Okay. What did we say? That 3 corresponds to the exact power that B needs to be raised to. I get Y to the third power. How do I build my other piece that goes with A, which in this term is X? The two powers need to add up to what? 15. What plus 3 equals 15? The answer is 12. So 15, 3. I'll go ahead and build that very quickly in the calculator. Turn it on. 15, math, PRB, NCR. Put in a value of 3. I come back with 455 x to the 12th y cubed. So that's a simple process. Again, the formula is useful. I have no problem with you using it. But I think you'll find this process, this step-through process, works quite nicely. Let's try it one more time. The ninth term in the expansion, 3x minus 2y to the 12th. Well, a equals 3x, b equals negative 2y. And I'll just grab parentheses around them for safety's sake. I want the 12th term. Remember, what do I start with? 12, 0. If I go away to the ninth term, I'm going to know it's going to look like 12, 8. There's my coefficient, okay? 8. B goes to that power. What's B? Negative 2y to the 4th. What's my other piece? A. That becomes 3x to the power 8. Let's do a little bit of work here. Figure things out a little. A 12, 8 becomes, let's go, 12. Math, PRB, NCR, 3. My 12, 3 turned into 220. Now, 3 to the 8th, it's not exactly my favorite number, but let's do it. 3 raised to the 8th power is 6,561. I'm going to have x to the 8th. Remember, I got to take both 3 and x to the power of 8. Finally, negative 2 to the 4th power is 16. And finally, sorry, I just missed that, but you can see all the pieces I've written as the camera zoomed out, my fault. And then y to the 4th. So I got everything built here. Let's work through. I know it's going to be x to the 8th, y to the 4th. And now all I got to do is multiply my different numbers together. 220 times 65, 61 times 16 equals, pretty big number, 23,094,720. So 23,094,720 x to the y, x to the 8th, y to the 4th. That's the process to work through for these types of problems.